Hello, welcome back. In this video, we will look at graph traversals. How do we traverse all the vertices in a graph? There are two ways, and one is called a depth-first search, and the other is breadth-first search. The result of the search, or you call it traversal, is a tree. The root of the tree is the starting vertex. You can pick any vertex to start, and that vertex will become the tree of the resulting search tree. So we're going to have this tree defined as this. In this class has a root, and you have the parent. So this is the parent. Every vertex in the tree has a parent except the root. So we're going to use a list. And so we're going to have something like this. This is parent brackets I. So that's the parent of the vertex with index I. So this is the search order. You start from the root and search all this vertices, and so you get the tree. So that's the search order. It's from the graph, you get this vertices searched in this order and put this in the list. And this is all the vertices in the tree. So this is the same as vertices from the graph if the tree is connected. And so this is the constructor to construct a tree with the root, parent, and search order, and the vertices in the graph. Get root. So this is the root of the tree. Get the search orders. Get parent. Get number of vertices found. Get a path. So this is the path is list. It's from a vertex, list of the vertices from the specified vertex index to the root. So that's the path. Print the path and print the entire tree. So we're going to use this for the breadth-first search and the depth-first search. And this is going to actually serve as the best class for the depth-first search tree and the breadth-first search tree. So now let's look at the depth-first search. Depth-first search of a graph starts from a vertex in the graph and visits all vertices in the graph as far as possible before backtracking. Let's look at this graph as example. So we're going to start from any vertex. Let's pick 0 to begin with. So 0, and now you can visit any of the three vertices, 3, 2, or 1. Let's pick 1. So now you have this 0, 1. And now from 1, we can visit 2 or 4. 3 is 1, 0 is already visited. So let's pick 2. Now from 2, we can visit 3, and 0 is already visited. So this is 3 now. And now from 3, no more vertex to visit. So we're going to backtrack to 2 and continue to visit. No, there's no more. And back to 1. Yeah, there's 1, is 4. And now we're going to backtrack to 1, no more. Backtrack to 0, no more. So all the vertices are visited. So this is the depth-first search tree rooted at 0. And here you see 1, 2, 3. And this is from 1 to 4. Then this is our algorithm for depth-first search tree. So the input is the graph. And here you have a starting vertex V. the output is a depth first search tree rooted at V. Now we're going to have this method depth first search starting from vertex V. First, we're going to visit the V. And for each neighbor W of V, if W has not been visited, so we're going to set V as the parent for W in the tree. Recursively invoke DFS starting from W. Now let's look at the, and this is the implementation here. So here, we're going to see the implementation. It's right. So this, the all right, here's the implementation. So right here. It's right here. So this is the implementation for depth first search. So let's look at this depth first search here, starting from V. So here's the search order, and this is the parent, the list. We're going to initialize all this. This is the -1, so it means we don't know the parent yet. So now this is the list is visited. So all of this vertices are not visited, so this is false. So now we're going to recursively, we're going to invoke this method. This is going to be a recursive method. And starting from V, and here's the parent, search orders is visited. And this is the helper method, and V, parent, search order is visited. So now we start from the V. So put V in the search order, append it. Is visited V is now true for every edge in this neighbor of V. So look at this W here. Is W visited? If it's not visited, so we're going to have to set this V as the parent for W. Recursively invoke W, and here's some parent here, and the search orders and is visited. So this is recursive depth first search method. After this method is finished, so we now can create this tree is V parent search orders, and this is the vertices in the graph. So now let's go back and to the steps for search. And so this is the implementation, and here's the test program. So we have vertices, we have the edge list, and we're going to create the graph using the vertices and the edges. And now we're going to invoke this and depth first search. And from Chicago is the index is 5, but you can use this get index for Chicago. And this is the to get the search order, depth first search, and get the search order and print everything. So this is all here is the vertices And this is the how many vertices are there. So you can get the number of vertices found. So here's the depth first search from Chicago and to Seattle, San Francisco, Los Angeles, Denver, Kansas City, New York, Atlanta, Miami, Houston, Dallas, and backtrack here, Boston, and you can backtrack all the way back to Chicago. So everything is visited. So there's a lot of applications for depth first search. You can use depth first search to detect whether a graph is connected. So we search for all the vertices if all the vertices are found, and so that the graph is connected. Detecting whether there is a path between two vertices, you can use depth first search. Finding a path between two vertices and using depth first search, finding all connected components. A connected component is a maximum connected subgraph in which every pair of vertices is connected by a path. So this is finding the connected path. If the graph is not connected, we can find all the components that are connected. Detecting whether there's a cycle in the graph, you can use the depth first search. Finding a cycle, yes, using depth first search. Finding a Hamiltonian path or Hamiltonian cycle. A Hamiltonian path in a graph is a path that visits each vertex in the graph exactly once. Hamiltonian cycle visits each vertex in the graph exactly once and returns to the starting vertex. So that is all for depth first search in this section. See you in the next section.